Hello everyone, today we're going to present about complex data analysis by using gate recurrent units technique. My name is Pasut Samjin.
And my name is Silapapasut. Here, our data we use for this technique is traffic flow data. First, primary data, we include the number of vehicles in 30 by 50 meter portion of Ngamungwan Road that run past Kasetsart University. The data contains time, number of car, number of motorcycle, and number of heavy vehicle, which include truck, bus, and some big van. The secondary data source is traffic flow data from TomTom API, which contain the current speed flow of the number one road in mile per hour and weather description from Open API that collect from the tower near the location we collect the data. Next, how we collect the data, we use smartphone with Node Mobile to take the data, take the picture every 30 minutes and send into FQTT server of Kasetsart University. Then that trigger to call the pre-trained model in RoboFlow to count the number of the vehicle in the road and call the TomTom API and Open Weather API, which of these will collected in the MySQL database. Why our data is complex? Our data is complex because it's collected from multiple data sources and it is time series data. Since collected data are stored in separate tables in relational database, we need to use the SQL query to integrate the data into one table. Here is the SQL query we use to integrate the data together. Here we will make the data into 30-minute interval. And here we will merge all the data all together. And then in the final table, we will get time, current speed, weather description, motorcycles, cars, and heavy vehicles. Now, we're coming into exploratory data analysis part. Here is an overall statistic of our data, and we found that the weather condition can affect the number of vehicles in road by seeing this graph and this graph. Now, next, how the time affected number of vehicle? Here, we use the line chart to represent the number of vehicle by time on each day of week. You can see that most of the day, the data are close together except on Friday, which is the effect from the earthquake incident. Yeah, you can see by day, and this will show the data of the speed flow instead. Now we can also see that on each time of day, the vehicle of each type having on the road are different.
Now let's talk about the analytic technique that we choose, which is a gate recurrent unit. So what is GRU or GRU eventually? Firstly, now let's talk about the recurrent neural network or RNN, which is a variant of neural network that takes sequence of data as a parameter, then inputs each data into neural network one by one. But there are feedback loop mechanisms that use the prediction of last value to be one of parameter or for current data. This is suitable for predicting time sequence value. But there is a problem with RNN, which is problem called exploding and vanishing gradient. So during the recurrent, a weight will multiply exponentially and can reach extremely high value, which is called exploding gradient, which makes the predict value unreasonable. On the other hand, it could extremely low and make the predict value very close to zero or vanishing gradient. Now this come to GRU. GRU add a mathematical function to the last part of the network to decide to keep or reset the vector of memory, which is called hidden state. from last recurrent step by input previous hidden state and current prediction and a parameter, then output a hidden state that got calculated from both gate, which is a reset gate and an update gate, which is another mathematical function. Okay, so let's talk about the GRU structure. First is the input layer. We take sequential data such as time series data as an input. Next is hidden layer. It's a layer where the recurrent computation occurs, and each time step hidden state is updated based on the current input and previous hidden state, which is a memory of previous input, and the reset gate, which is take a previous state and input and decide how much we should forgot. And update gate that take previous state and input and determine how much candidate activation vector incorporate a new hidden state. And what is a candidate activation vector? It is a modified version of previous hidden state that compute in the first place. And lastly, output layer. We take the final hidden state as input and produce a neural network output. Now let's talk about the pros and cons of GRUs. First, the GRU is pretty lightweight compared to other variants of RNN such as LSTM. GRU has less parameter and less complex. GRU requires computational power, but in return, it's not perform well as LSTM in terms of the complex data that have complex sequential pattern. But GRUs can handle long-term dependency. It can handle data by selectively remember and forgetting previous input, but is also prone to overfitting. GRU networks are prone to overfitting, especially on a smaller dataset. GRU also able to perform on a variety of tasks, both sequential to sequence and sequence to classification tasks. GRU networks have been shown that it's perform well on natural language processing and specific condition, but GRU is hard to interpret. Even though GRU has a less complex structure, GRU still consists of multiple complex mathematical functions that may be hard to understand how the network making prediction. Okay, now let's talk about the preprocessing. First thing first, I need to say that we have separated preprocessing into two parts. First is a before training preprocess. Certain processes are needed before training to make model work properly. And for the before training is some preprocess that we can do independently. And there are during training preprocess. Since this model also using for the coursework, we have aimed to let the model need only the value that true preprocess are able to perform independently from the dataset. Some of preprocess that depend on the dataset are included in the training process. Okay, firstly, we convert the hour and minute to decimal number. And we categorize the weighted condition. Since there are some weighted conditions that are very small example, so we decide to merge some of the weighted conditions that have some relative together, such as clear sky, few cloud, and scattered cloud. We interpret it as a clear. The broken cloud, overcast cloud, we interpret it as a cloudy, like that. So which make the sample is more a bit increased. Also, we label encode the day or week by the corresponding day. We transfer speed it, which is 8020. We have converted the dataset into multiple sequence of data and convert it to tensor, which is a required process before using the RNN model. And after that, the slide before is just a function, and here's when we actually do the sequencing, and we convert that into the tensor dataset and input into data loader for easier step when training the model. Now start to construct a model class. The model purpose is to predict the total number of vehicles on the road by using time, weather condition, and day or weeks as a parameter. And you can see that each part is structured of the model. GRU is where the GRU neural network occur, obviously. Linear is converting result from GRU network to be more interpretable. And layer norm is the normalizer. ReLU is preventing the result become negative. Okay, now let's talk about the processing type. The training process will invoke the forward method with a tensor as an input. Then forward will invoke the preprocessed param by taking input and extract some value from it and preprocess it. With the preprocess will convert hour to cycles format and one hot encoding the vector condition and they are weak. After preprocess, the input will go through each layer of network and output a prediction value. Now let's initialize the model and train it with the train data. So first thing first, we need to set up a hyperparameter, such as hidden size, which is the number of neurons inside the neural network, and numbers of layers, which is obviously is numbers of layer of neural network inside. And we need to prepare our criterion or optimizer. Then continue to training process that we have used the data loader that we had initialized before. Okay, for the measuring the performance, we use the MSE loss or mean square error for measuring the performance. By using the test tester we have split before, convert to sequence again, then measure performance with MSE loss. So we have measured the performance by training it for 10 times. Since the model have a different performance each time it got trained, so I have trained the model 10 times with same dataset to measure the average MSE. And average MSE we got is 17.84. And here's a reference that I used to learn about neural network. And that's it. Thank you.